So the first example says, how can you find the solution to x plus 9 times 5x plus 2 equals 0? There's a couple of things that are different about this problem itself. One of the major things is that even though it looks very similar to what we've seen in the past, it has an equal sign. So we're no longer dealing with just expressions. We're dealing with equations now because we have that equal sign. Another thing that we need to look at is it says that it's equal to 0. When we think about something that's being multiplied together being equal to 0, then let's let this equal A and this equal B. So A is going to be x plus 9 and B is 5x plus 2. For this left side of the equation to be equal to 0, then either A or B has to be equal to 0. The problem is we don't know which one it is. How do we know that it has to be equal to 0? Because 0 times any number is what?
0.
0 times 1 is
0.
And 0 times 1,000
0.
is still 0, right? And so for this to be 0, one of these two things have to be 0, but we don't know which one it is. So the way that we solve these types of problems is we break them apart. That's the first step. So we're going to put x plus 9, and we're going to set it equal to 0. And 5x plus 2 is equal to 0. And so that's what we call the zero product property. Basically, if this is equal to 0, we know one of these has to be equal to 0. We don't know which one it is. And so to solve this type of equation, then we are going to break them apart and set each one equal to 0. And then it becomes just a one-step equation, as in this one, or a two-step equation, as in this side. So remember when we were working these in class, we had something that we called SADMEP. And that's essentially PEMDAS backwards. And so our goal is to get x equals to something. How do we get x by itself over here?
Subtract.
Subtract what?
X.
So we could move the x to the other side. But
Subtract 9.
Subtract 9. I agree with that. I like it. I like to keep my variables on the left side. So if we subtract 9, what happens to the 9 on this side?
Cancels out.
Yep. And then what is 0 minus 9?
-9.
Yep. -9. Exactly. So there's one of our answers. And now we've got to do the exact same thing here. We want to isolate the x. And so according to SADMAP, we go subtraction, addition first. So what do we need to do?
-2.
And whatever we do to one side, we got to do to the other. So that'll give us the 5x is equal to what on this side?
-2.
And then what do we need to do?
Divide.
And so x is equal to negative 2/5. And we can double check that by saying so we had x plus 9 is equal to 0. And then we're going to plug in what we found for that side of the equation. Does negative 9 plus 9 equal 0?
Yeah.
Yeah, so that one works. Now this one, we had 5x plus 2 is equal to 0. And we're going to plug in what we found over here for the x. So 5 times negative 2 over 5 plus 2, does that equal 0? So what is 5 times a negative 2 over 5?
5.
What's 5 times a negative 2?
Negative 10. Oh, wait, I mean 3. Wait, hold on, what?
I don't know.
Oh, 5 times a negative 2?
Uh-huh.
Yeah, it's negative 10.
Negative 10 over 5 plus 2 is equal to 0. And then what is negative 10 divided by 5?
Positive 5, I think.
So how many 5s are in 10?
2, 5. Because 5 plus 5 equals 10.
Yeah, so there's 2, and it's a negative divided by a positive.
Oh, negative 2.
So negative 2 plus 2, does that equal 0?
Yes, it does.
Okay, so we're good to go there. Both of them check out, and that's just checking our work. So now, example 2 is a very similar problem, but we're going to incorporate our factoring ability. So example 2 says, how can you use factoring to solve, and it gives us this problem. X squared plus 9x is equal to a negative 20. So now this one looks just a little different. And one of the things that we have to do is we have to put it in standard form. And to put it in standard form, remember, that is ax squared plus bx plus c is equal to 0. So how can we get that right side to be equal to 0?
Plus 20. Positive 20.
Whenever we do to one side,
Do to the other.
yep. And so now we have x squared plus 9x plus 20 is equal to 0. So it's in standard form. Now they asked us how could we use factoring, so we know we're going to have to factor it. And we can go back to our puzzle that we're asking, what can we multiply to get 20 and add and get 9? And so that's when we're going to start looking at the factors of 20 that we can multiply together to get 20 and add together to get 9. So 1 times what equals 20?
20.
20. And if we added those together, that would be 21.
21.
So that's not it. 2 times what equals 20?
2 times
2 times
10.
10.
If we added those together, what would that be?
12.
12.
Will 3 go into 20?
No.
Mm-mm. What about 4?
Yeah.
4 times what?
5.
If we add those together, what do we get?
No.
9.
Is that what we wanted?
Yep.
Yeah.
Yeah, so we know that our factors are going to be x and 4x and 5. This is a positive 20. How do we get a positive number? By multiplying 2 positives and 2 what?
Negatives.
Yeah, and this is a positive 9. So do we want that 4 and 5 to be, we know they have to either be both positive or both negative. Which one? To get that positive 9.
Either way, right?
Well, if they were negative, we would have negative 4 minus 5, which would essentially be plus a negative 5. And so what is negative 4 plus a negative 5?
Let's see. Negative 4 1.
Negative 4 minus 5. So if you owe somebody $4 and you borrow 5 more.
Owe somebody $4 and borrow 5 more.
How much do you owe them?
9.
So it would be a negative 9. But we want a positive 9, so it would have to be positive 4 plus 5 to give us a positive 9. Does that make sense, Tanner?
Yeah.
All right. So we've got x plus 4 and x plus 5. So if we, and this is all equal to 0, and the reason why it's equal to 0 is because this, the equation that we started with before we factored, is equal to 0. So now we're going to set each side. Step 1, set that each side equal to 0. And how do we solve x plus 4 equals 0?
Minus the 4.
So we have x is equal to what?
0.
0 minus
4.
4.
Negative 4.
Negative 4, yep. And then how can we work with this one over here?
Minus 5 from both sides.
Yep. And so we have x is equal to 0 minus 5 is?
Negative 5.
Negative 5. And that's all there is to it. So you either start with the factored problem, which is how we did example 1, or you factor it and set it equal to 0. If you have to factor it, make sure that it's in standard form. It has to be in the ax squared plus bx plus c is equal to 0. That right side has to be equal to 0. Then you factor, and then you solve by setting both of them equal to 0. And that's exactly how we solve quadratic equations, by factoring. Are there any questions?
No.
Nah.
Tanner, you've been working on this, hadn't you?
On the thing, the work you sent out?
You've been working hard. So have you. Skylar's, he aced all this stuff. So y'all are doing a great job. Do you have any other questions?
Nope.
No.
Yeah, I'm good.
All right, guys.